Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to the lecture 6 of digital signal processing. I am Muhammad Atif and my registration number is 16D106. Today I will discuss decomposition and its types. First of all, starting from the superposition. Superposition is basically foundation of DSP. The only way signals combined is by scaling, which is followed by addition, and this is in case of linear system. The purpose of combining two signals through scaling and addition is called synthesis, and the process of synthesis is combining of signals through scaling and addition process. Through superposition, we can decompose a signal into two or more components. So, decomposition is the inverse operation of synthesis. Decomposition is also the inverse operation of synthesis, whereas synthesis is easy and decomposition is difficult. There are two major types of decomposition. Two major type. First one is step decomposition and second one is impulse decomposition. In step decomposition, now starting from the step decomposition, in step decomposition, n sample signals decomposed into n components, and these n components are also step. Let's take an example. I have a signal in which I have amplitude of 1 at 0, amplitude of 2 at 1, and amplitude of -1 at 2. This is x of n, and this breaks into three components. First one is x1 of n. In x1 of n, it starts from 0, which is 1, and it is constant through all the values. It is 0, 1, 2, 3, and it is constant. And the second component is x2 of n. It starts from 1, have an amplitude of 2, and constant through all other values, 2, 3. And the third one is x3 of n. It starts from 2, have amplitude of -1, and constant amplitude at all other values. So from this it is clear that n sampled signal decompose into n components, which is step. Now I will discuss minor type of decomposition, which is even, odd decomposition. In even odd decomposition, a signal breaks into two components. First is even symmetry and other one is odd symmetry. In even symmetry, x of en over 2 plus 1 equals to x of en over 2 minus 1, and in odd symmetry we have x of n of 2 plus 1 equal to minus x of 0 n of 2 minus 1. This means that the point at x of e1 equals the point at x of e minus 1. To calculate the composition, it can be calculated as x of e n equal to x of n plus x into n minus 1 divided by 2, and this can be calculated as x of n minus x of n divided by 2. Suppose I take an example, x of n equal to 1, 2, 3, 4, 5, and I have 0 index at 2. Minus 1, 0, 1, 2, 3. I have different amplitude at these values. So I have to calculate the even symmetry. X of 0 equal to 2 plus 2 divided by 2 equal to 2. X of e at 1 equals x of e at minus 1, and this will become as x of e at 1 I have 3, and x of e at minus 1 I have 1 divided by 2. X of e 2 equals x of e minus 2. 4 plus 0 divided by 2 equal to 2, as it is constant or same throughout the system, so it represents the even symmetry. Now the next minor type is interlaced decomposition. The interlaced decomposition breaks the signal into two component signal. Likewise, in the even odd decomposition, two component signal. The first one is even sample signal and the second one is odd sample signal. Here, not confused with even symmetry and odd symmetry, it is quite different from them. To find the even sample, we set all odd number sample to 0, and in odd sample similarly we set all even number of sample equal to 0. Take this example as I discussed earlier. To find the even sample, I set odd number equal to 0, 0, 2, 0, 4, 0, and for odd sample I will set all even number equal to 0, 3, 0, 5. This represents the odd sample and this represents the even sample. That is it for today. Thank you.